Yes, hi guys. I was just having this discussion, solving the question sixth number. Okay, now sixth question says that in this case we have to prove what is given to us. Let me revise it. Okay, revise it and make the revision of this whole question which we had done. Okay, now because there are some problem of time space in the camera, so I couldn't complete the topic here. So let me continue from here. Now, what we were given here, we were given that if tan u equal to cos x upon sine hyperbolic y. This is the sixth question here. If tan u equal to cos x upon sine hyperbolic y, and tan hyperbolic v is equal to sine x upon cos hyperbolic y, then prove that del u upon del x is equal to del v upon del y, and del u upon del y is equal to minus del v del x. Okay, this is partial differentiation. We are continuing. Okay, so we have to prove that this is with minus sign. Del u del y is equal to minus sign del v upon del x. This is sixth question, which I have just written down here. Tan u is this, tan hyperbolic v is equal to this one. Then to prove that del u del x equal to del v del y, del u del y is equal to minus del v upon del x. This is the second proof. This is the first proof we have to do. We have to solve these questions. Find out from this then u and tan hyperbolic v, or whatever values are given. Prove that these are equal to this. Now let me take this. We did this that u is equal to tan hyperbolic. Tan inverse. We have to take this tan to that side. That will be tan inverse cos x upon sine hyperbolic y. We can write like this. U is separated so that we can find out directly del u del x. We could do in the same way also, but that could take some time. So let me take this in inverse functions. Okay, and we know that what is tan inverse function. Tan differentiation of tan inverse x is 1 upon 1 plus x square. Okay. If it is tan inverse x, then it is differentiation 1 upon 1 plus x. And what is differentiation of tan hyperbolic inverse? That is one of the important points here. That is 1 upon 1 minus x square. If it is tan hyperbolic inverse x, then differentiation of tan hyperbolic inverse x is 1 upon 1 minus x square. This is the difference. This tan hyperbolic inverse x will be differentiated as 1 upon 1 minus x square time. Now we are differentiating with respect to x and y. Now let me take this equation number 1. This is second. We have taken v directly as v equal to this are written here, and v is equal to this is, and v is equal to v is equal to tan hyperbolic inverse sin x upon cos hyperbolic y. This is given to us. Now we differentiate the first equation partially with respect to x and y respectively. First, let me differentiate it with respect to x. We differentiated it with respect to x, keeping y constant. Okay, this is first. And when we differentiate with respect to y, then keeping x constant. This is partial differentiation. For that, this is required. Okay. So in this case, del u del x, we are differentiating with respect to x first. So differentiation of this will be 1 upon 1 plus this whole square. This is not the variable x here. This is something different from x. This is cos x upon sine hyperbolic y, but we are differentiating with respect to x. Only cos x will be differentiated again by function of the functionality. This is sine hyperbolic y is constant, but we are differentiating with respect to x. So keeping sine hyperbolic y constant, which is written here. Let me write it down here. This is cos x. We have differentiated this cos x as minus sin x. What I'm doing here. Okay. So differentiation of this. Sorry, this one. What I have to reach here. Okay. This is del e del x. This is this one. 1 upon 1 plus cos x upon sin hyperbolic by whole square. This is 1 plus x square. But this is not x, so we have to differentiate again. In the numerator, the cos x will be differentiated as minus sin x. Cos x differentiation is minus sin x, and sin hyperbolic y is constant, so we have kept it as it was. Okay, so sin hyperbolic y as it is, sin cos x is differentiated minus sin x. Now let me solve it. Here we take LCM sin hyperbolic square y. Here it will come sin hyperbolic square y plus cos square x, and this sin hyperbolic square y will come in the numerator. If we multiply this with sin hyperbolic square y, that means one sin hyperbolic y cancelled out, one sin hyperbolic x y, sorry, y will remain here in the numerator. This is minus sin x and into sin hyperbolic y divided by this value. Sin after taking LCM, LCM will be sin hyperbolic square y. Okay, so we will take this to this one into sin hyperbolic square y, that means sin hyperbolic square y plus cos square x divided by sin hyperbolic square y, that will come in the numerator. So we multiply this sin hyperbolic square by this sin hyperbolic y cancel out, one and one will remain. So this is the final value of this. So the third equation we have taken, value of del u del x. If we are able to find out, we will take that. Now let me find out what is differentiation of this function of u with respect to y. That also I have taken here, del u del y. Now we are differentiating with respect to y, keeping x constant. So it will be 1 upon 1 plus whatever the value of this tan inverse x is there, tan inverse x, but in place of x we have cos x upon tan apple y, that will be here. The same thing as we did here. Initial function is same, initial differentiation is 1 plus x square, but because this is different from x, so we have to differentiate it again. Now we are differentiating with respect to y, so it will be cos x will be constant, cos x is constant here we have taken. So it will be, if I take sin hyperbolic by in the numerator, the whole power will be minus 1. Then if cos hyperbolic by whole power minus 1 is differentiated, minus 1 sign will come before, then minus 2 power will be there. So minus 2 means sin hyperbolic by will come in the numerator, sorry, in the denominator will be square power, because here it will be in the numerator will be negative power 2, and here it will come positive power. Okay, but sin hyperbolic by is still to be differentiated. It will be cos hyperbolic by in the numerator. Okay, so this is total differentiation. Now in this case, sin hyperbolic by square, when we take LCM, will come here with this sin hyperbolic square by plus cos square x, and that denominator which was LCM will come in the numerator. If this sin hyperbolic square by which was in the denominator of numerator will be cancelled out. This will cancel out, sin hyperbolic by from denominator, and this numerator denominator of the numerator is this, same value will cancel out. So this cos minus cos x, cos or sin hyperbolic by is again differentiated, that will be cos hyperbolic by. Sin hyperbolic by is to be differentiated because we are different with respect to y. So this will be cos hyperbolic by, which is in the numerator. So cos x is already there, minus and this will be cos x. This minus sign, y minus sign has come out because when we differentiate cos hyperbolic, sorry, sin hyperbolic by whole power minus 1, then first division will be minus 1 into cos sin hyperbolic by whole minus 2 power into sin hyperbolic by is to be differentiated again. It will be cos hyperbolic by, which is here, and sin hyperbolic square by will come in the denominator. Okay, so this denominator sign and this denominator sin hyperbolic by will be cancelled out. So we will get this value. Okay, this is du upon du dy, or sorry, del u del y. Del u del y is this value. This is the fourth equation we have taken. So third and fourth. Now let me differentiate v with respect to x first, with respect to y then. Okay, partial differentiation. So this is partial differentiation. So first, if we differentiate with respect to x, keeping y constant, and we differentiate with respect to y, keeping x constant. Same thing here. Del v del x, we are differentiating with respect to x here. So, but in case of tan hyperbolic inverse y, will be first 1 upon 1 minus x square. This is 1 minus x square. Okay, when we did previously, I mean the leftover question, this was mistaken by mistake. Otherwise, I know this, that tan hyperbolic inverse x is differentiated as 1 upon 1 minus x square. So this is 1 minus whatever the value of angle is there in tan hyperbolic inverse, that value will come here. Okay. So this is tan x upon cos hyperbolic by whole square. But this is not x, again differentiation. So with respect to x, we are looking to sin x and cos x and cos x upon cos half by as it is this cos x upon cos half by c. But now cos square cos half square by in the denominator as LC will come here minus sin square. So this is in the numerator. This one cos half by will cancel out. So we cancel out and one cos half by will come in the numerator. Cos x into cos half by cos half by minus sin square. These are to be changed into numerical in case of this sin by cos, this is sin, but here it is cos. This is cos, here it is sin. So these are to be changed. Okay, so let me cos hyperbolic square by is 1 plus sin hyperbolic square by. So we have substituted in place of cos hyperbolic square by as 1 plus sin hyperbolic square by minus sin square x is 1 minus cos square x. If we open with the minus sign, it will be minus 1 plus cos square x. So, and 1 minus 1 and plus 1 will cancel out. The remainder will be sin hyperbolic square by plus cos square x. This is the same value as we get this. I'm sorry, this is minus sign. Okay, so this is with minus sign. We have got del u del x. This one is okay del v del x and del u del y. If we compare this fourth one, because it says del u del y, this is del u del y, del u del y, del u second answer, del u del y is equal to the first one, this one, del v del x, but with negative sign, because here there is no negative sign. Here we have negative sign. If we take this minus sign to this side, it will be minus sign with this the same value. Okay, so this is equal to the fourth is equal to fifth one with negative sign. This is with negative sign. So this minus, if I keep here minus del v upon del x, then it will be with negative sign here. Then it will be equal to this fourth one. Fourth and then fifth will be equal. So this is del u del y is equal to minus del v del x. We have multiplied by minus sign to del v del x. So this is the same thing we have obtained here. Okay. Fifth and fourth are equal. Now third, let me talk about. We have to find out then del v del y. Differentiate v with respect to y here. So this will be tan inverse, again the same thing. 1 upon 1 minus x square, that means sin x upon cos hyperbolic square by whole square. But now we are differentiating with respect to y. So this cos hyperbolic y taken to the numerator will have minus 1 power. That minus 1 power will be differentiated as minus sign before minus 1 into cos hyperbolic y whole minus 2 power. Okay, that minus 2 power will come in the denominator. That means cos hyperbolic square y will come in the denominator. But cos hyperbolic y is not x, so again differentiated. So cos hyperbolic y will be sin hyperbolic y with positive sign. Because in cos hyperbolic y is always positive, sin hyperbolic y. So sin hyperbolic y. But this minus sign has come why? Because when we differentiated cos hyperbolic y power minus 1, the difference was minus 1 into cos hyperbolic by whole power minus 2. This minus power has come in the denominator. Okay, so now in this case, we open this. Cos hyperbolic by will come here, cos hyperbolic square by minus sin square x. This cos hyperbolic square by and this cos hyperbolic square by will be cancelled out. So we have got minus sin x. Sin hyperbolic cos, sorry, this is sin hyperbolic by, because cos hyperbolic by is sin hyperbolic by. Sorry, this is not the answer. This we have sin minus sin x. So this is of this answer. This is here taken minus sin x into sin hyperbolic by is sin hyperbolic by divided by. Now this is cos square cos hyperbolic square by minus sin square x. This one again we have to change cos hyperbolic by and sin square x in the same way. This is equal to 1 plus sin hyperbolic square by cos hyperbolic square by equal to and sin square x equal to 1 minus cos square x. Now open this with minus sign, this will be minus 1 and this is plus 1, cancel out, and sin hyperbolic square by plus cos square x. Now we see that sixth one and third one. This Third result, minus sin x sin approved by minus sin x sin approved by divided by sin square sin approved square by plus cos square x. The same. So third one and sixth one are the same. So del u del x equal to del v del y. Del u del x equal to del v del y. This is the first answer. Okay, we have obtained. Second one also I obtained with negative sign. So this minus sign we multiply. Okay, so these two results are obtained. This is your question number 6 now completed. Now let me take the seventh question and another sheet. So then these 12 questions are to complete today. Let me solve the remaining questions so that this exercise will be over then. Then we will take the next exercise based on the same topic, I mean partial differentiations, because this is a lengthy chapter, lengthy exercises. Now let me take seventh question here. Seventh question has some parts, I think three parts, four parts are there. Okay, so find, it says find del z del x, del z del x, and del z del y. So differentiation with respect to x and with respect to y, where z is given in each case. Seventh question is find del z del x and del z del y. If first a part, it says if z equal to, a part says z equal to 1 upon, let me write here, 1 upon under root x square plus y square. This is value of z here. Okay, in first a part, z equal to 1 upon under root x square plus y. So this is seventh question, part 1. Okay, part A. Now let me differentiate with respect to x, with respect to y, then values are obtained. Okay, so differentiating this first equation, differentiating first with respect to x, keeping y constant, keeping y constant. Okay, so keeping y constant, then del z del x, this is equal to, now if we take this in the numerator, let me write here del x of x square plus y square whole power minus half. Now let me differentiate it. We have taken this square root power in the numerator, it will be negative minus half power. If we differentiate this, it will be minus half power first. It has been multiplied plus x square y square whole power, now minus half minus 1, that is minus 3 by 2. If we add minus half minus 1, by put here minus 1 sign, that will be minus 3 by 2 over. Now because this x square plus y square is not x only, so we have to differentiate it again. So x square is differentiated, y square is constant, so 0. So this is twice x only. Now 2 cancel out. So we obtain here minus sign x upon x square plus y square whole power 3 by 2 positive. This is value of del z del x. Simple. If we take this in the numerator, with the negative sign minus 3 by 2, only x minus x upon this. Now what is del z upon del? So differentiating now with respect to y, differentiating first, okay, with respect to y, with respect to y, keeping z constant, that is understood. We have not write it again and again, this is understood, because we are finding out partial differentiation. This is del z upon del y, del z del y simply, okay, will be equal to differentiation of this with minus half over. It will be minus half before x square plus y square whole power minus 3 by 2. Again, this x square plus y square is not x, sorry, not y, so we have to differentiate again. It will be twice y, x square will be 0, because we are not differentiating with respect to x, we are differentiating with respect to y. So only y square will be differentiated again. This is 2 cancel out. This is nothing but minus y upon, okay, x square plus y square whole power 3 by 2 positive. This is the answer here. These are the two answers. Okay. First part A is solved. This is how we have to find out differentiation with respect to x and y. That is simple question here. Now let me find out B part of this. There are certain tricky questions which are given. Now B part says z equal to Here z equal to log of e x square plus y square. This is x square plus y square. Okay, this is b part. Again differentiating this first. Let me write here differentiating first with respect to x and y respectively. This is partial differentiation. So understood. We are not right again like that when we are differentiating with respect to x keeping y constant, and we are differentiating with respect to y keeping x constant. This is understood. We are differentiating with respect to x here. This is del z del x is equal to first log differentiation log x is 1 upon x. So this is log, this whole value will come in the denominator. It will be x square plus y square. But since x square plus y square is not x, we have to differentiate again. Differentiation, let me write it as of x square plus y square again. That will give us 1 upon x square plus y square into denominator. X square will be differentiated, y square is 0. This is twice x on. This is nothing but twice x upon x square plus y square. This is first. Okay, this is second. Let me take answer. Now differentiating with respect to y, del z del y is equal to the same thing, 1 upon x square plus y square. Log first differentiate 1 upon x square like, or 1 upon x type, 1 upon x square plus y square, because this is the same thing. Now again differentiation of this, so del y of x square plus y square, that will be twice y only. This is twice y divided by x square plus y square. This is the answer here. This is third equation. These two are the answers, del z del x, del z del y. Okay, so these are the two answers. So part B only del z del y and del z del x we have to calculate. Now part C. What is the part C says? So let me take part C. Part C of seventh question says this one, z equal to, here we have z equal to tan inverse. Okay, this is tan inverse x square plus y square plus y square upon x plus y. Okay, this is the value of C part here. So tan inverse. Differentiating this first, that let me write here. Differentiating first with respect to x and y respectively, keeping first y constant and then x constant. Simple. That is understood. With respect to x and y respectively. First with respect to x keeping y constant, and second with respect to y keeping x constant. Understood. Del z del x is equal to 1 upon, first of all, tan inverse is 1 upon 1 plus x square type formula. This is x square plus y square divided by x plus y whole square into differentiation of this. Well, this is not x. Let me write here del x of x square plus y square divided by x plus y. If we differentiate this, it will be here. Let me write. This is x plus y whole square plus x square plus y square whole square. This after taking LCM, and this LCM will come in the numerator. So this is x plus y whole square. The numerator, this denominator will come in the numerator into, now differentiation of this. This is quotient rule, something upon something, a ratio form. So quotient rule is to be applied for differentiation. So this will be denominator x plus y as it is, differentiation of numerator. Now differentiation numerator is only x square. We are differentiating with respect to x. It will be twice x only. Y square is 0. Then minus sign in between. Now x square denominator, sorry, numerator as it is. Differentiation of denominator is x only 1 divided by x plus y whole square, because we square the denominator. So square of denominator is x plus y whole square. Now this x plus y, because this is multiplication, are cancelled out. What we get, this value will come in the numerator. This is twice x square plus twice xy. We multiply by twice x to x plus y. We get this value. Minus x square minus y square divided by this one. This is x plus y whole square plus x square plus y square whole square. This will give us, in the numerator we have 1 x square cancelled out. This is x square, okay, with minus sign. This is x square, okay, x square minus y square. We take plus twice xy minus y square divided by whatever this value. No need of solving it because different terms will be obtained. Only this is, okay, the sum of this. If I open this, this will be x4 plus y4 plus twice x square y square. From this x square plus x square plus y square plus twice x y. So all the terms will be separated. So they are not, I mean, combined. Okay, so no combination of any two terms will be there. So only this is the answer. This can be written like this. Okay, here it is also not whole square of anything. We cannot summarize this again. Now del z upon del y. Del z upon del y. Let me write. Okay, so here we were differentiating with respect to x. Okay, now we have to differentiate with respect to y. So del z del y, the same thing. First differentiation is similar. 1 upon 1 plus x square because it involves y as well. So it will be the same thing. 1 plus x square plus y square upon x plus y whole square into del y of this whole value. This is x square plus y square upon x plus y. Let me write the proper method here. Now let me differentiate this. So it will be again x square, sorry, x plus y whole square will come in the numerator. This x plus y square after taking LCM, x plus y whole square will come in the numerator here. This is x plus y whole square plus x square plus y square whole square into this differentiation again by quotient through this x plus y denominator first as it is into ddx of this, I mean ddy of this, del y of this, so it will be twice y only, minus sign in between. Now x square plus y square numerator as it is, denominator of, sorry, differentiation of denominator will be only 1. Since no y is 1, x is 0, so we are differentiating with respect to y differentiation is 1 only, divided by x plus y whole square, the square of the denominator here. So this the same thing we have obtained again, similar type. Okay, this will be, here it is twice xy plus twice y square minus x square minus y square divided by x plus y whole square, this one, plus x square plus y square whole square is equal to this minus y square and plus 2y square. So we will have y square minus x square plus twice xy divided by x plus y whole square plus x square plus y square whole square. This is the answer. No any further solution of this because it cannot be summarized further. All the terms will be different in the denominator. Let me, this is the answer. Okay, so this is del z del y of part C. Now part D is there. So now part D says, for the part D here, let me take that. Now part D says z equal to, okay, part D of 7th question is z equal to x raised power y. This is first equation. Now if I take logarithm here and after the differentiation, that will be better. So first take logarithm, taking log on both sides, taking log on both sides of first, both sides of first. So this will be log z equal to y into log of x y because we know that log of m raised power n is equal to n log m. This is the formula which we have applied here. Log of x raised power y is by log x. Okay, y will come before, power comes before. So this is logarithm of these two functions. Now differentiating this is, let me take second equation. Now differentiating second with respect to x and y, again respectively, because we are partially differentiating respectively. So first differentiate with respect to x, keeping y constant, then with respect to y, keeping x constant. So this is uh, differential with respect to x first. It will be first one point z, but del z is a function of x and y, so it will be del z upon del x. We are differentiating with respect to x here. Okay, so this will be here y is constant. Sorry, y is constant. Why? Because we are differentiating with respect to x. It will be 1 upon x only into log x is 1 upon x. Log of e x basis a e. It will be y upon x here. What is del z del x? Therefore, del z del x equal to z into y upon x. But what is z here? Substituting value of z, that means x raised power y into y upon x. Okay. So if I substitute the power of x is here 1, it can be further written as y into x raised power y minus 1. Why? Because we have taken the x power above. X raised power is y. This minus, this 1 power will come in the numerator, then it will become negative. So y minus 1 power here. Y into x raised power y minus 1. This is the final answer here. Okay, answer. Now, and let me write here del z del y equal to, sorry, del z del y means we have to differentiate with respect to y. And this 1 upon z again into del z del y. We are differentiating with respect to y here of second. We have written here with y respectively. Now we are differentiating with respect to y. It will be 1 point z again, but z we are differentiating with respect to y, so it will be del z del y. That is equal to, now y here, y is 1, only log of ex is left over. Because differentiation of y is 1, log ex is constant, so log ex constant is as it is. Okay, so keeping this as it is. Okay, del z, therefore del z del y is equal to z in